Hello, Sweet Tips here. I'm at the jeweler's bench, and what I'm going to do now is go ahead and demonstrate how we've set up a vacuum system here to actually go ahead and vacuum the gold dust out of the jeweler's drawer. And we've got a water filtration system here. Got it hooked to a shop vac, and I've got the flask set up so that the vacuum's drawing on the flask, and then the material's coming up through this hose, going down through and bubbling into the water so we don't create a dust cloud and we can recover all the gold.
The jeweler is continuously filing, cutting, and grinding on fine jewelry made of gold, platinum, and silver. As a result, the precious metals filings and clippings accumulate quickly in the open drawer just below his work area.
This is the jeweler's bench block here. This is where he does all his cutting of rings. You notice that the drawer is open underneath, so we're catching all that gold down in here. And use the device that we've created here to get the gold out of this drawer. Here we go. What we'll do next is take this and boil off the water and do an incineration, and I'll recover the precious metals out of this out of these bench sweeps. First step is to I'm going to siphon the water off. I got a little tube here. I'm going to fill it full of water. Put my thumb over one end, put the other end down into the flask with the water. I'm going to siphon it off here to my waste bucket. Before I get it real hot over here, I want to go ahead and evaporate this water off, and then I'm going to check through this for any diamonds that might be in that waste. It's been on here evaporating now for a couple hours, I guess, and it looks like it's dry as a bone. Looks like we've got 102.6 grams.
Before I incinerate the material on high heat, I carefully pick through it looking for loose diamonds and other stones, and to get a look at what I have. I pick out the stones that I find and I set those aside to give back to the jeweler. I could just use a fine sieve and sift the large pieces out to make this job go much faster, but I prefer to do it manually.
Okay, I've been through it one time now, and what I'm going to do is I'm going to turn around and go through it again. And this time I'm going to pick out the big pieces of carat gold that I find and put them to the side so we can import stuff in here. There's some wood, there's some pieces of staple. I've seen a couple of fingernails in here, some saw blades, there's some lint, there's hair. Here's a piece of carat gold. I'm going to set them over here. I got all the carat gold little pieces in the pile there. I'm gathering those up. Picking through this stuff like this takes a long time, but I don't care because it appeals to my meticulous nature. Okay, I've got a preliminary sorting completed. Here's our initial material. What I've done is I've dug through it twice, and I found these pieces of carat gold, I believe. Pieces of gold, silver. And I picked all those out. As I was going through, I found some stones, and I picked those out and put them in here. Give them back to the jeweler. And this is just a bunch of magnetic stuff that came out of there. I ran a magnet through it. So what I'm going to do now is go ahead and melt this material into a button. Put this into the melt dish. We'll melt that up into a button and check the carat. I'm going to do now, I've melted it into a button. What I'm going to do now is test it on this touchstone. I'm going to rub a little bit of sample on there. I got some testing needles here. I'm going to use 14K on the left over here. And on the right, I'm going to use a 10K needle. And then we'll put some acid on there and see what kind of reaction we get. It's looking like it's closer to the 14K than it is the 10K, but not quite as dark. I'm going to go ahead and call this probably like a 12K. And our button weighs 24.6 grams. We're going to call it 24.6 grams of 12K gold. So yeah, I've got 12K, 24.6 grams, 24.6 times 0.5. 12K is 50% gold. So I multiply that by 0.5, and that equals 12.3. There's 12.3 grams pure gold in our 24.6K button. Multiply that by 3, so I got 1/4 gold and 3/4 silver. So that's times 3. I get 36.9 grams of silver. I take the 24.6K button, subtract the 12.3 grams of gold that's in it, and I get 12.3. Of course, 50% gold, so 12.3 grams of our 24.6 gram button is non-gold. So we're going to subtract that from the amount of silver that we're going to add. So we take 36.9 minus 12.3, and we're left with 24.6 grams of silver. That's how much silver I need to add. I'm going to multiply this by 0.9, and I get 22.14. That's how much we'll put in. That's how much silver we're going to put in. Okay, I got the silver prepared here. I got 22.1 grams of silver. What I'm going to do is add this button to the melt dish. And I'm going to add the 22.1 grams of silver to the button. Then we'll go out and melt this. And stir it with a graphite rod and pour in some water. Now I'll pour out the tap water, add the gold to a 600 ml beaker, and then give it some rinses with distilled water.
The distilled water rinses will rinse off any chlorinated tap water that remains on that gold. We do not want the chlorinated tap water in with this reaction because it'll form silver chloride, and that will make filtering a little bit more difficult later on.
Now I add about 150 ml of distilled water for the reaction. Now I'm going to add some nitric acid. That's about 75 ml. Turn the heat on over here. about medium low. I'm going to go ahead and set this on the heat and let this cook. Turn the heat up to just a touch above medium.
In this time-lapse sequence, notice how the fumes increase and then begin to decrease as the nitric acid is consumed by the reaction. It's important to have plenty of distilled water in there so that the dissolved silver and other base metals have some place to go.
There's no more fumes in here, so what I'm going to do now is go ahead and dump this into my silver jar, because this liquid is going to contain a lot of silver and maybe some platinum group metals. So I want to save this. I'm going to pour it in my silver jar here. You can see the encorded gold down in there.
Notice that the gold is holding together in large pieces. If it starts to crumble into a powder, then that means that too much silver was added during the inquartation.
Sometimes a little bit of gold might get poured over. When I'm rinsing this off, that's okay, because I filtered this out and recover the, now I'm going to add about 100 ml of water. This is distilled water. Set it back on the heat. I'm going to add some more nitric acid here. I'll put about 50 or 75 ml in there. And then we'll continue to let this boil. The encorded gold has been on here boiling now for, good another hour and a half at least. What I'm going to do here is go ahead and pour off this hot acid. It's still good and can be used again. So I'm going to pour this off into my container here of used acid. Rinse the gold out real good here. Pour a rinse into my silver jar. I'm going to add some distilled water, about 100 ml again. Set it back on the heat. Now I'll add some more nitric acid, probably about another 75 ml again.
This is the third dilute nitric acid treatment.
The gold has been on this third nitric boil here for about 2 or 3 hours. And as you can see, the color is crystal clear, meaning that all the silver and all the base metals have been removed from that gold. It's nearly pure gold in that beaker right now. Take it out, dump this used nitric into the storage container. I can use it again to dissolve more silver. Rinse the gold. Distilled water. Pour it off into my silver jar. I'm adding hydrochloric acid to the gold now. About 100 ml or so. Then I'm going to place it on the heat. Turn the heat down to low. I'm going to add a half an ml of concentrated sulfuric acid to precipitate out any lead. Now I'm going to add some small doses of nitric acid. See if I can get that gold to dissolve. But I can get this gold to go into solution with about, I shouldn't take much more than 5 or 6 ml. That was 2.5. That's 3.5. And that's 4. So I got 4 ml of nitric acid in there now. The gold's been on the heat here with 4 ml and nitric acid in it for about half an hour now. And as you can see, just about everything is in solution. It's got a few little bitty grains left in there. So I'll add a few drops of nitric. We'll get that to go into solution, and then I'll go ahead and cool this off so we can do a filtration. Okay, I got just a few drops of nitric in here. I'm just going to go ahead and I've swirled the beaker to get everything to accumulate in the center there. We'll go ahead and add some, just a few drops of nitric on top of that solid material in the beaker to see if we can get it to dissolve. This is another good point to make. I just added about 5 or 6, maybe 7 drops of concentrated nitric acid to that hot hydrochloric acid and chloroauric acid solution. I placed it right over the top of the solids inside that beaker, and I didn't see any reaction at all. So it may not be gold that's in there. It might be something else. It might be dirt. This came from a jeweler, so it might be carborundum, which is the abrasive that comes off of the discs. So rather than keep adding nitric acid to that, I'm going to go ahead and stop here, pull this off and cool it down. If I keep adding nitric acid and that stuff doesn't dissolve, what I'll end up with is a whole bunch of excess nitric acid in that solution. And that's something that I want to avoid. So I'm going to go ahead and turn the heat off, pull it off and let it cool down so I can do a filtration. As you can see, there's just a little bit of material down in the center there that didn't go. Now we'll add some ice, get things cooled off here so we can do a filtration. I'd just like to point out, I learned this, learned something new from one of my viewers, that silver chloride is actually soluble in water very slightly. And if you noticed when I pulled this off of the heat, that it was pretty clear. But now that I've added ice and cooled the solution down, the silver chloride has come out of solution and made it just a little bit cloudy there. And that just goes to show you this is a learning process that's two-way. One of the viewers, I think the guy's name was Owl Tech, I believe, he pointed out that silver chloride is soluble in water. It's more soluble in warm water than it is in cold water, so that's why we add that ice. By adding the ice, we get the silver chloride to drop out of solution, and then it becomes available so we can filter it out. The solution's been cooled with ice now down to about the temperature of a glass of cold iced tea. So now what I'll do is go ahead and we're going to filter this solution with my vacuum filtration here. Got a filter paper in here, it's already been moistened. I'm going to go ahead and start the filtering. As I suspected, the little bits and pieces that were left in the bottom of the beaker when I was trying to dissolve the gold are not even gold. It looks like there's little bits of maybe some of the abrasive that the jeweler uses when he's working on the jewelry. And then we got a little bitty thing here, a little bitty BB, it looks like of maybe platinum group metal that didn't go into solution. So it's a good thing I didn't start adding a whole bunch of nitric to get all that to go into solution. I'd have a whole bunch of excess nitric down in here right now if I'd have done that. I've got a slight bit of cloudiness down here in my filtrate. So what I'm going to do is I've set up a second filter flask. I'll go ahead and put the funnel over here. It's got the same filter paper in it as before. And I'm going to go ahead and put the solution through that loaded up filter paper a second time, see if we can get this solution to clear up a little bit better. I'm going to transfer the chloroauric acid solution to a clean beaker here so we can precipitate it. Precipitate the gold with some stump out here. Stump out is sodium metabisulfite, also known as SMB. piece of filter paper here. I'm going to dip it down in our solution and make sure we got all the gold out of solution with some stannous chloride, and see if we got any other kind of metals in solution with it. And I can see a slight tint of orange. I don't know if that's visible on the camera. It's got a slight tint of orange to it, which tells me that there's some platinum in there, but just a trace amount. It's not worth going in and trying to refine this platinum out of here. It's going to be less than 1/10 of a gram probably. I'm going to go ahead and add this to my stock pot and cement out the platinum on some copper in my stock pot.
I add the waste solution that has a trace of platinum in it into my stock pot. If I pour a little bit of gold off into my stock pot, that doesn't matter because I'll be refining that and recovering it later.
Now I'll get the gold into a filter paper here. I'll give the gold a quick rinse with a little hydrochloric acid. Now I'll put the filter and the gold back into the beaker. It's been rinsed out real good. Now I'll add about 100 ml of hydrochloric acid to the filter, and just like before, we'll cover it up. Put it on the heat over here, low heat. Add about 1/2 ml of concentrated sulfuric acid.
The sulfuric acid will precipitate out any lead.
Now I'll start adding small doses of nitric acid here. That's about 3 ml in there. That's about 4.5 ml. That should do it.
In this time-lapse footage, I show the gold dissolving with just 4.5 ml of nitric in there in just 10 minutes.
And as you can see, everything's gone into solution. The filter is completely disintegrated, and we'll get that filtered out when we filter this solution. Just wanted to show you the bottom of this beaker here, just to verify that everything's gone into solution in just 10 minutes with 4.5 ml of nitric acid. Take it off the heat now and let it cool down so we can filter it.
I add 4 ice cubes to the hot chloroauric acid solution to get it cooled down before I filter it.
The solution's real cold now. It's got some ice floating around in it. Go ahead and pour it through this filter now and go ahead and get a good filtration on this.
The solution to a clean beaker to prepare for precipitation with SMB. Now I add the stump out, which is SMB or sodium metabisulfite, to precipitate pure gold powder out of this solution. After settling for about 1/2 hour, I pour off the waste solution to my stock pot. Now I rinse the pure gold powder into a filter paper. That's a nice caramel color. That's what we want to see. Next, I transfer the wet filter paper and the gold into a small melt dish. And here's the culmination of all my efforts, a small button of pure gold.
And here's our final product. Little gold button, pure gold. Should be 3/9 fine, easy. And we're weighing it at 9 grams even, 9 grams. Alright, that does it. That concludes part 1 of the jeweler's bench drawer sweeps. This is the 9-gram gold button that I got from the carat gold pieces that I picked out of the bench sweeps. I quartered them with silver, and then we did a standard refining with it, and I estimated it to be 12.3 grams, but it actually turned out to only be 9 grams, as you can see here. Must have been a little bit more silver, a little bit more other stuff in there. Anyway, that concludes the first part, and what we'll do is on part 2, I'll go ahead and process the rest of the scrap that came out of that drawer, the small little filings there, and I'll start with incineration, and then we'll go from there. So, I'd like to thank everybody for watching. This is the first half. Part 2's coming very soon. Thanks for tuning in. Thanks for viewing this video. And y'all have a good night. Thank you.